Students, in this video we will be dealing with the problems on the diode chapter, that is PN junction diode and its applications, module 1. Here we are going to have a relationship between the current flowing through the diode and the voltage applied to the diode. This you can see. This is the equation we have. Diode current relationship. Diode current and voltage relationship it is. So here ID is, I stands for current, you can understand. ID is the current flowing in the diode, current flowing through the diode, whereas here VD is there. E raised to k into VD divided by TK is there. VD is voltage applied across the diode. And here one more current is there, that is IS, which stands for the reverse current flowing through the diode, IS. Then K is one constant which is given as 11,600 divided by N. That N stands for, N is equal to 1 for a germanium diode and N is equal to 2 for a silicon diode it is. Tk is temperature in degree Kelvin. Tk is temperature in degree Kelvin. So now ID is the current flowing through the diode, that is forward current flowing through the diode. IS is the reverse current flowing through the diode. VD is the voltage applied across the diode, and K is one constant. Tk is temperature in degree Kelvin. So which is clearly written here. ID is current flowing through the diode. Is is reverse current through the diode. And K is 11,600 divided by N. It is one constant. N is equal to 1 for germanium. N is equal to 2 for silicon. Then VD is the voltage applied across the diode. Tk is temperature in degree Kelvin, which can be calculated as Tc plus 273 degrees. So what is this? Tc is operating temperature in degree centigrade, 25 degree centigrade. So how the problem will be asked here? They'll give you all the parameters here. Reverse current they'll give, the voltage applied across the diode they will give, and the temperature they will give, and they may ask you to find this ID, that is the forward current flowing through the diode. That is one type of a problem. Or all other parameters they'll give, they may ask you to find IS, reverse saturation, reverse current flowing through the diode. Or they may give you all other components except VD, and they may ask you to find VD. What is VD? Voltage across the applied across the diode. These are the three possibilities of getting problems on this relationship: finding ID, or finding IS, or finding VD. We'll go through all three types of problems here. In the first problem, what is given in silicon diode? They have mentioned silicon diode, which is having IS is 10 nanoamperes at 25 degree centigrade. 25 degree centigrade they have given. ID for a forward bias of 0.6 volts. So what values they have given here? IS value, TC value, VD value they have given. And what formula we have? We have this formula. So parameters we'll calculate first, like Tk. Tk is temperature in degree Kelvin. What they have mentioned is in degree centigrade they have given. We should calculate this one in degree Kelvin. So that is going to be Tc plus 273. This formula we had discussed previously. So Tc, that is temperature in degree centigrade, they have given it as 25. 25 plus 273 will give you temperature in degree Kelvin. Then after that, K value will calculate 11,600 divided by 2. Why divided by 2? Why not 1? Means they have clearly mentioned silicon diode. So it is 2 we have taken. Then we have calculated this value, K value. Then K into VD divided by TK will calculate. VD is given, K you have calculated, TK also you have calculated. So this value E raised to 11.68 directly you can substitute here after calculating it previously. So E raised to K into VD divided by TK. These all parameters you have calculated previously, which comes out to be 117,930. That you have applied here. IS is equal to E raised to K. This value you have applied minus 1, which comes out to be 1.18 milliamperes. So what is done here? In this formula, this is calculated first so that we can substitute it directly here in the formula. This is directly given. K you have calculated 11,600 divided by N. N you have put it as 2 because silicon diode is mentioned. VD is directly given. Tk you have modified it, 25 degree centigrade they have given, you have done it in degree Kelvin. So after doing this, calculate this value particularly, then you can directly substitute it to get the value of ID. This is finding ID is the first problem. In the second problem, what you have is the forward current in a PN junction diode is 1.5 milliamperes. Means forward current means current flowing through the diode. ID they have given here. ID they have given if at 27 degree centigrade means TC also they have given. You need to calculate Tk here. It in reverse saturation current is, this means IS value they have given 2.5 into 10 raised to minus 14 amperes they have given. What is for n is equal to 1 means it is a germanium diode. Instead of saying germanium diode, directly they have given you n is equal to 1. What is the forward biasing voltage across the junction? What is the forward biasing voltage across the junction? That is VD you need to calculate. For that, what you are doing? Given parameters you have directly written ID, TC, IS, n is equal to 1, VD. Now TC is given, you can calculate Tk as it is done here, 27 plus 273. Then K value 11,600 divided by n they have given it as 1. Now ID is equal to IS into e raised to k into VD divided by Tk minus 1. In this we need to find VD here. This they have given, this they have given, Tk they had given, K you have done. So you need to calculate VD here. So minus 1 can be neglected here. If you neglect it, the calculation becomes easy. So by neglecting minus 1, we will be having ID is equal to IS into e raised to k into VD divided by Tk. So that e raised to k into VD divided by Tk will be ID divided by IS in order to calculate VD, which is done here. Neglecting minus 1, you have taken e raised to k into VD divided by Tk is equal to ID divided by IS. ID, IS you know, you can get the value here, ID by IS. E raised to 11,600 point VD divided by, that is dot VD divided by 300 here into VD divided by 300. From this we need the formula for calculating VD here. So taking natural logarithm on both sides, will come to this equation 11,000. This becomes the ln of natural logarithm of 6.25 into 10 raised to 10. If you calculate, you will be coming to 24.858. So taking ln on both sides, you will get for equation thus. Then from this VD can be easily calculated. VD is equal to this into this divided by this will give you VD, that is voltage applied across the diode, so many ohms. That means second type of problem in which you are finding, this is the formula, you are finding VD here. To calculating VD, what you are doing, e raised to k into VD divided by Tk is equal to ID divided by IS you are taking, neglecting minus 1. To calculate VD, what you are doing, e raised to k into VD divided by Tk is equal to ID divided by IS, neglecting 1. Then taking natural logarithm on both sides, you can get the equation for VD, and substituting all the parameters which you